So we continue with this in this video, looking for the points at which a graph of a function has a horizontal tangent line. And we've been working with some quotients, functions that are rational functions. And we saw in 73 that we could rewrite, when it's a simple denominator, we can rewrite using negative exponents and multiply out and use the product rule, which is simpler than using the quotient rule. Of course, though, the quotient rule would work just as well. But in problem 74, we saw that we can't use that type of rewriting because the denominator x squared plus 1, when we move it up, becomes x squared plus 1 quantity to the negative 1. And we can't just distribute into that as long as there's a plus sign or a minus sign in there. So instead, when we go to look for the derivative, we're going to go directly to the quotient rule. So sometimes a rewrite will be helpful, sometimes it won't, and we'll have to go ahead with the quotient rule. So f prime of x is low, the denominator, times d high, the derivative of the numerator, minus high, the numerator, d low, the derivative of the denominator, all divided by the denominator squared, which is x squared plus 1 quantity squared. Now we do need to simplify the numerator. We get 2x cubed plus 2x minus 2x cubed over x squared plus 1 quantity squared. Now when we simplify, the 2x cubes become a 0 pair, and in the end we're left with 2x over x squared plus 1 quantity squared. Now we want to find out where this is 0, and a rational function is 0 whenever its numerator is 0. It's undefined when its denominator is 0. So quite simply, this derivative will be 0 whenever 2x is 0, and that means whenever x is equal to 0. And that does it for this problem. We'll scroll down and look at problem 75, which is similar to 74 in that it cannot be rewritten and multiplied as a product. So in problem 75, we have f of x is x squared over x minus 1. And we're going to go right to the quotient rule. And so f prime of x is equal to the denominator, x minus 1, times the derivative of the numerator, which is 2x, minus the numerator, times the derivative of the denominator, which is 1, and all over the denominator squared. We'll simplify the numerator and get negative 2x squared, then minus 2x, then minus x squared, and all over x minus 1 quantity squared. So one last simplification, 2x squared minus x squared just gives x squared, then minus 2x over x minus 1 squared. And we're looking for where that's equal to 0. And we know that a rational function is 0 when its numerator is 0. It's undefined when its denominator is 0. So all we have to do is set x squared minus 2x equal to 0, factor out an x, we'll be left with x times x minus 2 times the quantity x minus 2, and that will be 0 whenever x is 0 or 2. And we'll take a look at problem 76 then. In problem 76, we have f of x is x minus 4 over x squared minus 7. Again, this is a similar situation as the previous two problems, which cannot be rewritten to make a product. So we'll directly use the quotient rule. And that's low, d high, which is 1, minus high, d low, which is 2x, all over the denominator squared. We just need to simplify the numerator. Get x squared minus 7, then minus 2x squared, and then plus 8x. We'll do one more simplification on that. That will be negative x squared plus 8x minus 7 over x squared minus 7 quantity squared. I'll factor out a negative from the numerator. That will leave me negative quantity x squared minus 8x plus 7 over x squared minus 7 quantity squared. Now x squared minus 8x plus 7, that's going to factor to be x minus 7 times x minus 1, and a rational function is 0 when its numerator is 0, and it will be 0 whenever x is equal to 7 or x is equal to 1. And so that does it for this type of problem. Hopefully it's clear how we go about finding the place where the function has a horizontal tangent.